Hi, and welcome to Chapter 2, Lesson 3, the subtraction of real numbers. So, last lesson, we looked at the addition of real numbers. And now, this lesson, obviously, we are looking at the inverse operation, subtraction of real numbers. So, our subtracting rule, or our subtraction rule, is a two-step rule. Our first step, or our first part, I should say, because there's actually two steps in our first part. But the first part is to change subtraction into adding the opposite. So we're changing the subtraction into adding the opposite. So that first part, if we look down here at example 1a, it's 4 minus 9. So the first change we make, we change the subtraction sign into addition. And then it's 4 minus a positive 9 originally. So then we change the sign from a positive to a negative. So we're adding the opposite. So you change from subtraction to addition and you change the sign. So sometimes this double change will be referred to as the change process or cha-cha. That's what I use to remember it. Cha-cha stands for change, which is change subtraction to addition and change the second number's sign. Or you can just think of it as change subtraction into adding the opposite. So you're changing the subtraction into adding the opposite. So minus 9 is adding negative 9. And then once we've changed subtraction into adding the opposite, we simply follow our addition rules from our last lesson. So example 1, we have quite a few parts, but it simply asks us to find each difference. And remember, the word difference is the answer to a subtraction problem. So we are simply being asked to subtract. So in part A, like we already looked at, 4 minus 9, we change subtraction to adding the opposite. So it'd be 4 plus a negative 9. And then following our addition rules, 9 minus 4 is 5, and we have more negatives than positives, so it's a negative 5. In part B, we have a negative 4 minus 9. So we change it to a negative 4 plus a negative 9. So we're adding the opposite. So you never change the sign of the first number. That always gets left alone. Change subtraction to addition, and change the sign of the second number. And then we have a negative 4 plus a negative 9. Follow our rules of addition, negative 13. And then in part C, 4 minus a negative 9. So we change subtraction to addition and change our second number's sign. So it becomes 4 plus 9, which gives us 13. In D, negative 6 minus 3. Change our subtraction to adding the opposite again. So it becomes a negative 6 plus a negative 3, which gives us a negative 9. In E, a negative 15 minus a negative 6. So the first number never gets changed. So that's still a negative 15. Change our subtraction to adding the opposite. So the negative 6 becomes a positive 6. Negative 15 plus 6 is a negative 9. And then in part F, for fractions, 1/2 minus 2/3, we still follow the same subtracting rules of changing it from subtraction to adding the opposite, but you also need to remember in fractions that we need common denominators. So if we have a 1/2 minus 2/3, So we change our subtraction to addition, and the positive 2/3 becomes a negative 2/3. So we have 1/2 plus negative 2/3. With our denominators at 2 and 3, we'd have a common denominator of 6. So 1/2 is the same as 3/6. A negative 2 over 3 is the same as a negative 4 over 6. Then we simply combine our numerators. A positive 3 plus a negative 4 is a negative 1 over 6. So we have a negative 1/6. In G, H, I, J, and K, we have more than two numbers. So we have multiple operations, but they are all subtraction or addition. So we simply work them left to right. So if we look at G, we have 10 minus 5 plus 14 minus a negative 18. So first thing, I'm going to take care of switching my subtractions to adding the opposites. So when I rewrite this, it would be rewritten as 10 plus a negative 5 for the 10 minus 5 plus a 14, and then the minus negative 18 becomes a plus 18. So now it's all addition. Then 10 plus a negative 5 is 5. 5 plus 14 plus 18 gives me a positive 37. In H, 4 minus 7 minus, or 14 minus 7 minus 12. So our subtraction gets changed to adding the opposite, so it becomes 14 plus a negative 7 plus a negative 12. 14 plus a negative 7 is a positive 7. 7 plus a negative 12 gives us a final answer of negative 5. In I, even though it's decimals, we still follow the same rules and then work it left to right. So changing our subtraction into addition, our problem becomes 1.3 plus a negative 1.9 plus a 4.2 plus a 2.6. So all of our subtractions became adding the opposites. Then we work it left to right once it's all addition. So a 1.3 plus a negative 1.9 is a negative 0.6. A negative 0.6 plus 4.2 plus 2.6 is 6.2. And then in J, again, we want to remember we'll eventually need a common denominator because we're adding fractions. But first, I want to take care of changing the subtraction into adding. So our minus a negative 3/4 becomes plus 3/4. So our problem becomes 7 over 12 plus 3/4 plus negative 1/8. Now 12, 4, and 8 all multiply into 24. So our common denominators would be 24. Multiply the top by whatever we changed the denominator by. So for example, the negative 1/8, 8 times 3 was 24. So on top, a negative 1 times 3 gave me a negative 3 over 24. With the 3/4, 4 times 6 was 24. So the top gets multiplied by 6, giving us 18. And then the 7/12, the bottom was doubled, so we have to double the 7 on top to give us 14. So then we end up with 14/24 plus 18/24 plus a negative 3/24. Add across left to right, and we end up with 29 over 24, which we can rewrite as 1 in 5/24, because we can take 1 whole of 24 out, and that would leave us with 5 out of 24. And then in K, remember the vertical lines around a number means the absolute value, or how far from 0. So that always gives us a positive number. So we have 6 minus the absolute value of -2 plus the absolute value of -7. So I'm going to apply my absolute values first. So this becomes 6 minus a 2, because the absolute value of -2 is just a positive 2, plus the absolute value of -7 is 7. 6 minus 2 is 6 plus a -2, and then plus 7. So 6 minus 2 is 4. 4 plus 7 is 11. And then the final part that we're looking at for this lesson is the idea of creating an input-output table. So there's a few different ways input-output tables may look. It might be 2 columns, on the left input, on the right output. It may be 3 columns, where in the middle it is the work, or showing the work, for the solution on the right. So in example 2, they ask us to make an input-output table and use -2, -1, 0, and 1 for our inputs. So our inputs, if we're ever given an equation with y and x, the inputs are always x, the outputs are always y. So in our input-output table, our inputs, they gave us -2, -1, 0, and 1. I'm going to substitute those in for x. So when we put in a -2, we end up with 12 minus a -2, which would be the same as 12 plus 2, giving us the output of 14. When I put in a -1 for x, 12 minus a -1 is 12 plus 1, or 13. Put in a 0, 12 minus 0 is simply 12. Put in a 1, 12 minus 1 is 11. So this is our 3-column input-output table. I could simply convert that or represent that as a 2-column input-output table with the inputs on the left, outputs on the right, or simply known as a T-chart because of the shape right there. And then in part B, you'll see again, I made the 3-column input-output table to show my work in the middle. Again, we're going to use -2, -1, 0, and 1 for our inputs. And our equation is y equals a -5 minus x, or we would simply read this as the opposite of x minus 5. And I believe I said that backward originally. So this could be y equals a -x minus 5, or y equals the opposite of x minus 5. So typically, if we ever have a negative sign in front of a letter, we read that as the opposite of the letter. So our inputs go in for x. So we would have the opposite of a -2 minus 5. Well, the opposite of a -2 is a positive 2. So 2 minus 5. 2 plus a -5 gives us the output in -3. When we put in a -1, the opposite of -1 minus 5, so 1 minus 5, or 1 plus a -5, gives us a -4. Put in a 0, the opposite of 0 is still 0, so 0 minus 5, or 0 plus a -5, gives us the output of -5. And then with our input of 1, the opposite of 1 is a -1. So -1 minus 5, or -1 plus a -5, gives us our output of -6. So as you work through today's practice problems, again, you want to make sure that you're comfortable with the rules of addition, because our subtraction rule is we change subtraction into adding the opposite, and then we follow the rules of addition to solve.